Good morning, guys. So today we're going to be taking notes on proportional versus non-proportional relationships. And these pertain to linear relationships. So they will either be proportional or they will be non-proportional. And a proportional relationship means that there is a constant change between the value of X and Y. So with proportional relationships, there's different representations or how they can be represented. They can be shown as a graph, a table, an equation, or a verbal description. Now, in order for a graph to be a proportional relationship, it must satisfy two requirements. Requirement one is that it must be linear. Okay, that means that it must be a straight line. So I'm going to go ahead and add that in. Must be a straight line. Requirement two is that it must go through 0, 0. Okay, it has to go through both, it has to satisfy both of those requirements. So an example of a graph that is a proportional relationship is this graph right here. Okay, and I want you to notice that this graph satisfies both requirements. It is a straight line and it's going through 0, 0, or it's starting at 0, 0, which is also called the origin. Now, if if given a table, the way that you can tell that this will be a proportional relationship is that it's going to have a constant ratio, which is m. Okay, it's going to have a constant ratio. And the way that you're going to find m is simply dividing the y and the x value. So here is my example of my graph. Okay, so let's look at it. The way I would do this, I'm going to do y divided by x. So I'm going to take this 5 and divide by x. So 5 divided by 1 equals 5. 10 divided by 2 also equals 5. Oops, sorry. If I were to do 15 divided by 3, guess what? Also equals 5. And then my last one, if I were to do 20 divided by 4, that will also equal 5. And because all of my numbers, let me fix my line spacing. See if I can get it all to fit. Oops. Let's just see if I can, sorry. Okay. So all of my numbers are the same, and that is a constant. So my constant is 5, okay? Or that's my constant rate of change. Now, if I were to have an equation, the way that I can tell that an equation is a proportional relationship is that my equation is going to say y is equal to mx. Okay, y is equal to mx. Notice there's no adding, there's no subtracting, and the reason there's no adding or there's no subtracting is because I am starting at 0, 0. So my y-intercept would be 0. And if I were to do the example from the table, the way I would write this is y is equal to, my constant was 5, so I would just put 5x. Okay, and that is my example from this table here. Okay, and lastly, my verbal description. So the description should suggest there is no constant. Oh, sorry. There is a constant rate of change without addition or subtraction. Okay, so the description should suggest there is a constant rate of change without addition or subtraction. Okay, and this should seem very familiar because we have actually seen all of this before, and I am going to insert a text box because another word for proportional relationships is, can you guess? Is direct variation. If you say direct variation, you are correct. That means that if a graph, a table, an equation, or a verbal description, if it is a direct variation, it is also proportional. If it is proportional, it also varies directly. Okay? All right. Let's move on to non-proportional relationships. And I can see already this is not right. So let me change this. And yours will already be fixed. Okay. There we go. Okay. So with a graph, a non-proportional relationship could be either non-linear or does not go through 0, 0. So if it's linear but doesn't go through 0, 0, it's non-proportional. If it goes through 0, 0, but it's like a squiggly line, it's also not a non-proportional relationship. Okay. If it does any of the one of these, it is non-proportional. Now with your equation, you can have two. You can either have y is equal to mx plus b, or you can also have y is equal to mx minus b. Okay, now we have those components of addition and subtraction. So in the description, the verbal description should suggest there is no constant rate of change or addition and subtraction. Okay, so they can say that there is no constant rate of change, or they can say that you're adding or subtracting. If you are adding or subtracting, that is a non-proportional relationship. And finally, your table, there is no constant rate of change. So that means when you have your table and you divide all of your y's and your x's, it's going to give you all kinds of crazy numbers. So for example, I have this table right here. Sorry. Okay. So here is my graph. If you notice, it is linear, but it starts at 8. Sorry to backtrack. It starts at 8, so that is an example of a non-proportional relationship. And when I come and do my graph, this is what happens. So if I'm doing 30 divided by 2, I get 15. 90 divided by 8, I get 11 and 25 hundredths. If I do 150 divided by 14, I get approximately 10.7. Because all of my numbers are different, that means there is no constant rate of change. Okay, so zooming out, okay, remember proportional relationships are direct variation. They are the exact same thing. Okay, and of course, all of the opposites would be a non-proportional relationship. And if you have any questions, please let me know. Otherwise, we are done for the notes. And you guys have a great day. I will see you later.